this is just a little project I did mostly to learn how to 3D print and have a bit of a play around. So when Raspberry Pi stock came out, I got interested again in buying shares in a company. So I bought some shares in the Raspberry Pi, and I thought, well, it's not, you don't want to be constantly looking at your phone just to see what the share price is. So I thought I'd build something to show me what the share price is during the day. So obviously you can just go onto any device and sort of look it up, but I wanted something that's more physical than that, something you can just look at. So yeah, I just want to see how it's doing. So this is some prints of how it actually went. So I bought the stock early on here, relatively early when it first came out, and it sort of went up this big mountain, and then it sort of plummeted off. So it's either wow, I'm going to retire early, or it's, oh my God, I have to work forever. So that's the sort of what it feels like. I don't know if anyone else owns shares, but when you own shares, you sort of get pretty invested in it. So yeah, I want to use a 3D printer. Stepper motors, I've used stepper motors in the past, but I haven't really spent a lot of time with them. So I just wanted to learn a bit more about them, particularly zeroing the stepper motor. I think is obviously a very important thing to do. I just needed a project, so decided to build something. So it's under construction. So this is, yeah, just something I'm just working on. It's not anywhere near complete, but as Frank, just want to share stuff early on, and I need a presentation. So it's one of the reasons why I'm always working on stuff, because I need to, just in case a presentation is needed, I need to be able to, sorry, I'm just figure something over here. Okay, there we go. Yeah, so under construction, still working on it. So this is what it looks like. So it's all 3D printed. So if the share price is exactly the same as yesterday, then the dial will be straight up. And then if this is like minus 5%, can't quite see it very clearly because the photo doesn't work out very well. It just gives the price in the UK on the London stock market. It's all in pence. So this is 531 pence. And this over here, so this is minus 5% from yesterday's close and plus 5% from yesterday's close. I think it says 587 or something like that. Then it gives the time and the current price. So I know if it's straight up and down, I know that I haven't lost any money today. If it's all the way down here and it swings past the minus 5%, I know I'm going to have to work for a few more years. If it goes all the way, I can have a beer in the evening. But that's what it looks like. It's not very fancy yet. So this is LED screens, little LED matrices shining through the 3D print. So if I change videos for a second, so you can see the actual in my video feed there. You can see it working away there. You can see the red arrow there. It's well past the minus 5% bit. So it's at 481 pence per share at 15:55 in the afternoon. And if you're wondering about scale, this is a banana for scale.
So it's continually updating?
Yeah, that's right. It's continually updating. It's just running because it's running through today's data because the market's closed at the moment here in the UK. But it would continually update. I haven't quite sorted that bit out yet. So this is the end of the day. So it's sitting there for a while. It's on pause while it just waits a bit, really. That's all it does. So what it looks like in the back is this. It's a bit of a mess, but you've got the Pi W2 talks to one of these Pimoroni scroll FATs. And then it also talks to a read switch, which is in this little board here. And then it also talks to this FAT hub, which talks to 3 other scroll FATs. So those are just the LED matrices. And then to control the stepper motor, it talks by this L298N device. That's a motor controller, which you can see here in the red board. And then that talks to the stepper motor. So all these cables I built all these cables myself, just crimped them all myself, did all the soldering myself. So it's all just obviously handmade. It's quite clear it's handmade. The reason why some of the stuff is askew, I just haven't figured out how I'm going to fasten everything. And when you work in 3D printing, you end up spending a lot of time like reprinting things, changing things slightly. So I didn't want to make anything too permanent yet. So I'm fully happy with the design. Yeah, so that's how it works. The Pi W2 talks to the internet, gets the information. The read switch is just so that it zeroes itself out. So it has to figure out where 0 is. So at the start of the day, it will, when you start it powered up, the first thing it'll do is swing around until there's a little magnet on this end. And it'll swing till the magnet gets the read switch, gets the power, and then you know where 0 is, and you have a little bit of an offset to figure out where so that it's pointing straight up and down. And therefore, after the stepper motor goes, then you step up or step down depending on which way the sock is moving. Hopefully that makes sense. Scroll FAT HDs. So this is what it looks like. It's the size of a Pi W2 or Pi W, Pi 0W or W2. They don't make them anymore, but I think other companies make similar things. It's an I2C device, so you talk to it by I2C. It has a fixed address of 0x74. The library that Pi Moroni provides assumes there's only one of them. So you have to hack the library a bit. So all I do is I just, essentially the library says, when you go to write something to the LED matrix, it says, do I have an LED matrix already? If it does, you can't add another one. It won't accept a new address or new I2C channel. So you pass it, the library, you pass a I2C channel and the I2C address that you want to talk to. So if you've already started one, you can't start another one. So you just have to like zero out the library. So it's something I need to work on. I want to make it a little bit fancier with improve the scrolling and stuff like that. Yeah, but one of the things with the Raspberry Pi, normally you've got 2 I2C channels available, but it turns out you can build as many as you want, but you have to add a 1.5K pull-up resistor. So essentially, the I2C protocol requires that. I think it's just one. Is it two LED? It assumes the clock is high and the data is high. So you need to add the 1.5 resistor in. And this Instructables and this YouTube channel explain how to do that. So you can see here the little board that I wired up. You've got the various pins, or the pins coming in from the Raspberry Pi. And I've got 2 hats, 2 I2C hats driven by this connector, and 1 by this connector. And then you've got obviously power 3.3 volts and 0 volts coming in here. And then I've had to add these 1.5K resistors into each of the clock and the data pins to make the I2C protocol work. So yeah, it's mostly just, this board is just to split out, just share the power and the ground. And it's also to add the 1.5K resistors in, so that's all it does. The fourth scroll hat is driven directly from the Pi with the normal I2C address. So stepper motor, I don't know if everyone knows how a stepper motor works, but essentially all you're doing is controlling the magnets to rotate the rotor. So there's a little animation here just showing how that works. So you're applying magnetic force to hold the stepper in place, and then you change the magnetic force to move it. And the key is you keep track of how many steps you've done, so then you know where the stepper motor is. And as I mentioned, that means that you have to know where you started. So that's why you need some sort of zeroing process. That's where as I mentioned, the little switch comes in, the reed switch comes in. So yeah, the motor control looks like that. So you've got the four inputs here. So it's for the controlling the magnets, and you've got two inputs for this magnet and 2 inputs for that magnet, and those go directly out with a little bit of signal conditioning and stuff like that. And you've got your power obviously coming in, 5 volts in and ground in. As per all these sorts of devices, you have to have a shared ground. So you have to tie this ground to your Pi ground and your power supply ground. They have to be a common ground. Otherwise, it just won't work. And the I2C, there's an explanation of how the stepper motor works here at this link. That's where I got this animation from. So yeah, this is the stepper motor that I've got. It's a little NEMA, I guess 17 motor. It's quite powerful actually. So it will, obviously I'm not overworking it. Got a tiny little mass on it. It's not really doing much work. It's much more powerful than that. Yeah. And the reed switch. So very simply, the way a reed switch works is you just need a magnet here, for example, and it'll pull up this reed into this one, and that'll complete your electrical circuit. And yeah, so all I do is on my dial here, there's a little magnet at the end here, and it swings towards the reed switches. The magnet will pull on the reed switch, this bottom part here. It'll make contact. The Raspberry Pi will pick that up, and it'll realize that's where the 0 is. It is a bit finicky. It takes a while to get worked. This has to be oriented correctly. So obviously you put a magnet over here, it may or may not work. If your magnet's too far away, it may not work. So I just added an extra magnet in to make it work when I needed to. Just increase the force. So I did the 3D design via Fusion. So that's what that looks like. So this is the faceplate with the dial, and then behind there I've got all the hardware and connectors to connect the various devices. So one thing I learned about 3D printing is that you don't really want to be printing out this big sheet, because that'll take over an hour to print out. If all you want to do is get very precise about this holder, for example, to hold the LED matrices. So you end up sort of doing little prototypes where you build the holder, for example. You go through 4 or 5 revisions of that, and then once you're happy, you can transfer that over to your full design quite easily. You just sort of say, I'm going to take that over and put it in my main design, and then you can incorporate into that main design. So just a bit of lessons learned there. So I got the Bamboo Lab P1S. So this is their mid-range printer. It's quite good out of the box. About 15 or 20 minutes later, you got it working. It's not a cheap one. It's about 700 pounds with this AMS, which stands for automatic material system, or automated material system, I think. It holds 4 reels of filament, and you just when you're doing a print, just say which filament you want. It does multicolor printing and stuff like that, but I haven't done that sort of stuff yet. The AMS thing, I guess I was originally thought I'd get it without it, just get the base printer and just not worry about it. But when I talked to my brother who also has one, he insists on paying for my AMS because he says such a big upgrade. He wouldn't let me have a printer without it. So he sent me the money to buy it. So fine. That was what big brothers do for you, right?
Sometimes.
Yeah, at least my big brother did. Yeah, so it's a reasonable purchase for me. I don't regret it. I think it's a good printer without going way overboard. You can spend a lot more money, obviously. It's not open source. It's not really for fiddling around with. You just sort of does what it does. Not a lot of customization available.
Have you used the different color filament feature a lot?
I have used all the different colors. I haven't combined the colors though.
No, but like, have you used it with 4 different colors in one project?
No, I haven't yet. No.
Okay.
So physical stuff. So I found that I did spend quite a bit of time. So little 2.5 millimeter bolts work quite well. You can screw it into PLA, which is the printing material, quite easily, or not quite easily, but with some difficulty. So I think we're probably better off with 2.5 millimeter screws to go into the 3D print. You could obviously glue it as well. Epoxy will work or hot glue will work. I will probably end up using screws in my final designs. The 3D printing isn't precise enough to do the threads. You can ask it to do the threads, but at 2.5 millimeters, you're not really going to get decent threads out of it. It does try, it just doesn't really work. I just doesn't have the precision with this type of printer. I really like these Molex stackable linear connectors. They're very good. I use them on this project. I think I'll use them on any project in the future that I can. The thing I like about them, they're very robust. They have this locking mechanism. That means you can't put them in, and they're polarized. That means you can't put them in backwards or anything like that. So you're not gonna actually fry anything. They sell separately little locking mechanisms. So if you click this in and you don't want anything to move around, you can buy this extra lock thing in there. That'll keep everything nice and tight. So it's be good in vibration as well. And they also sell them. So this is obviously wire to wire, but then they also have various board connectors as well. So you can do almost anything that you need with these type of connectors. You just have to buy the other types. They're also compatible with DuPont connectors, which is what the Pi has. So this type will plug in directly to most boards that you buy off the shelf. Connect to Picos and stuff like that. Although you don't have the locking mechanism, but it's the same pin and size. When you're building the cables, particularly on the Pi side, if you're connecting to the DuPont connector, one thing I found, I don't know if everyone realizes this, but if you just have a bunch of individual connectors, one wire connectors, then you end up, just gonna change my video. If you have a bunch of one wire connectors coming in, they're not very robust. Like they easily get pulled out and stuff like that. But if you take those same one pin connectors and you remove the actual crimp contact from that housing and you put it into a 40 pin connector, then you get a nice tight fit because of all the other physical constraints. So I really recommend doing that. Even going from a 4 1-pin connectors to 1 4-pin connector makes a big difference in how tightly your cable connects to your Pi or any other board for that matter. So it's definitely something I recommend. To keep your wires or your custom cables nice and tight, it's worthwhile braiding them as well. So if you braid them, like here, you can see I've done a poor job braiding this one, but this one's braided quite a lot better. It also helps keep your pins together as well. So if there's a little bit of pulling on this, it sort of keeps it all together. I've had heat shrink on there as well in the label, but it's just really good to have something that's keeping all your wires together. So, 1 pin isn't pulled on too much. If it gets if it gets caught in something or it gets pulled for some reason, it's not, 1 pin's not going to pull out. They all sort of strengthen each other. And if anyone's broken their finger, but all you do if you break your finger, you tie it to the one next to it. It's the same sort of idea. Sort of a splint. So the data for this just comes from this library called Yahoo Finance. Really simple to use. I've used a lot of these sorts of getting data from the internet in the past. A lot of my projects used to do it, and they're always fairly complicated. And you're looking at JSON and stuff like that, and you've got your API keys that you have to get and register for the API, etc. This one was literally, you sort of import Yahoo Finance and you say, here's all the stocks I want to hear about, tell me about them. And it sends you back a data frame, a Panda data frame, which is quite easy to use. It was the first time I used Pandas, but it's very, very powerful and it's quite easy to use. So I do recommend find this sort of interface. If you're not interested in stocks, then there may be an interface that is similar. So a Panda data frame interface is quite easy to use. You can also use JSON as well. There's lots of good libraries for processing JSON. So yeah, that works really well as well. It's just, this was like one step easier even.
So how do you go from that website data to importing it into the Pi?
Well, it comes from that data format, and then all the data frame. The data frame is it looks a lot like an Excel spreadsheet, or it has columns and rows. So all you do is just say, give me all the columns or all the rows or whatever you want. You just manipulate as if it's a spreadsheet. Yeah, in Python, obviously.
Okay.
I can show some code later if needed.
Yeah, I don't really understand that part, but maybe you can kind of show me what you mean by the data frame.
Yep, I can show you that. So in the future, so really if I don't get bored, move on to something else, I'll sort of improve the displays. I may add like another display that sort of gives more of a traditional stock market type display. It's gonna be a lot richer display if you had like a little screen that shows the ongoing graph or something like that, rather than what I've got at the moment, which is so just to have a little bit richer data as well as this. Lots of 3D design improvements I could do. Could add more stock and more features and things like that. I think I will probably make it so that it can run over the last 6 months, the last 3 months of data, and you can sort of see how it's done over the last 6 months, the last 3 months, whatever you want. I don't plan on adding buttons, so it may just run through a sequence of things like that. Yeah, so just to conclude a bit, so it's not really a very complex project, relatively straightforward. There's a few things I learned, obviously, really helped me with some 3D printing skills, sort of do some 3D designs. It's always good to practice your crimping and your soldering and things like that. I find it quite therapeutic. You sort of just think about what you're doing. It's sort of like doing a jigsaw puzzle, isn't it? It's just not, that's not mentally taxing or anything like that. It's just doing stuff. But it is quite uh, relaxing and interesting. Not necessarily interesting, but it's relaxing and it occupies the mind. Yeah, so this is a couple of AI pictures I asked to be generated with ChatGPT. So this is Raspberry Pi at the stock market. Not a proper Raspberry Pi, obviously, it's an AI generated one. And then I said, well, draw me one with the stock market crash. And they're actually showing the stock market crashing, and there's flames burn. Not exactly what a stock market crash is. But yeah, that was quite funny. So that's the project. So I thought I'd just give a little bit more detail. So let me just.
You've frozen on the screen.
Frozen. Give me a sec. Okay, so let me share something else here. I'll share my screen. Okay. Let's see that now.
Yeah.
So the design. Sorry. It's being a bit finicky. Sorry, just give me a sec. Okay, so this is the 3D design. So I don't know how many people are used to 3D design CAD software. This is Fusion 360, so there's my design there. So you can see there's the dial, there's the faceplate, and behind you can see in light blue, you can see all the different various device holders I've got behind there. And then it's also got a model of the stepper motor. So if I rotate it around, you can see the stepper motor here. So you just import that into your file. So then you can use that to make sure everything's going to fit together. So I've got that there. I just got that off of, I forget what it's called. There's a website that just offers these models. People just scan them or they measure them with calipers or whatever. Yeah. So you can sort of see the dial here. You can see the dial here, and this little part here. So I just turn off some of the components. So I turn off the stepper motor. I turn off the case. And that just leaves me with the dial. You can see here underneath, you can see this little piece here. This is where the magnet goes in. So I just put the little magnet in there with a little bit of blue tack. And then what I also realize is you don't really want to, if you do that, you'll have to have a way of getting it out again. So I put a little hole in here as well, just so I could poke it out with a paper clip or something if I need to. So yeah, you can just see. So it's this Fusion 3D Fusion product is really good. They allow you to use it free for 3 years. And then after 3 years, you have to validate yourself again. I think all they do is they just don't want anyone using it for commercial purposes for free. So if you make over, I think, £3,000 or $3,000 a year from their CAD software, they want you to pay.
Yeah,
So I
it's a
think all they do,
thousand. It's 1,000.
1,000, okay,
Yeah,
1,000.
yeah, it's the same as the self-employed declaration level.
Okay, cool. Thanks for that.
That's all right. I only found out myself the other week.
Yeah, I think it's really excellent software. So there's lots of good tutorials on it. I guess that's the other good thing about it is you can find loads and loads of very, very high quality tutorials. The one I use is called Learn Fusion 360 in 30 days. It was really good. You can just skip through the ones that you don't think are going to add any value to you. Like there's one on there how to make a mold and stuff like that. But I don't need to do that.
Yeah, I've looked at it, but it does have a fairly steep learning curve.
It does, but I think it's worth it.
Yeah, I've kind of experimented with simpler versions of CAD software.
So yeah, so this is the code that does the so I don't know what people use for your Python code, but I found PyCharm is really excellent. So PyCharm, this is a community version. It's available for free. And again, yeah, it's for personal use. So you just download it and get it running. It's really very simple. And it's very, very good. Very, very powerful. It's got things like here you've got, it's got tips and hints. If you break the Python, I forget what PEP it is, but it's essentially all the coding standard, the Python coding standard, the PEP 15 or whatever it's called. Then it'll tell you that you're not meeting the coding standard and will flag that up. So for example, if I delete a few lines here, it will say that's not
It's called PyCharm.
PyCharm, yeah. And it also allows you to do things like if I want to replace all instances of, if I want to rename things, like maybe I don't want to use the word symbols, I want to use, stock symbols or something like that, then it'll replace all instances of that. That's actually in the code. It won't place the stuff in the comments, for example. Things like that. It'll go across all the different files in your project and things. It's just so powerful. And the only thing I'd recommend if you're using it is always pay attention to all this stuff down here, all these warnings. If your warnings aren't clean, then you're doing something wrong. You're better off cleaning them up, because otherwise your code's probably not going to work anyways. So using the library is very simple. So you can see here, this is some test code that I built. So all it does is, so you pass it the ticker data. So ticker data is equal to this, Microsoft, Cisco, Google, Raspberry Pi.London. And then you, so then you just create the ticker data here. And then you get ticker, then, so this just passes you. So this passes, so you create the object here. So that's creating this object here, ticker data. And then it's just saying, get the data. So that's all you have to do. And then it comes back with all the code. So then this is just saying, take all the code that you've got for Raspberry Pi and put it through a dictionary. And then I just run through the dictionary and print it out or whatever I want to do. So that's just the simple code. And obviously my main project just creates this ticker data class or object, and then just reuses that to get the data every once in a while. So that's all you do.
do you ever use GPT to create code?
I haven't yet. I haven't yet. No.
Okay. I'm really new to using Python, and so I've been using it a fair bit, and I still have a lot to learn, but it does help.
Yeah, I guess yeah, but I'm sure I'll try it at some point. I haven't yet. Cool. So that's a quick run through my project. Don't think I've forgotten anything. Yeah, it's just a little bit of playing around, really.
Yeah, that looks pretty cool.
Any questions from anyone?
No, it looks really good. That it looks like it's taken a lot of time and effort, but it looks really, really good.
Yeah, I guess yeah, it doesn't look as fancy as over here. It's fairly plain. It's fairly
It
plain,
looks
but
fancier in your head. Is it one of those?
yeah, I think one thing that I did like playing around with quite a bit is the part where you've got the LEDs shining through the faceplate.
Mhm.
So I think that's quite a good. I'm sure it doesn't show up very well. It doesn't show up very well on the video camera,
No,
but it's
there's too
actually
much
very,
light.
very clear in real life. The thing you have to be aware of is that when the LED matrix has to be very, very close to the surface. If it's too far away from the surface of the plastic, then you'll get blurry. And the
Oh,
plastic
so
has
they're
to be very
acting like a
thin.
lithophane.
Sorry,
Is it acting like a lithophane?
I don't know what that is.
Where you take a photograph and you can 3D print a photograph effectively, put it up against the light, and it looks like you can see it.
Yeah, it's only one layer thick.
Yeah.
I've done a bunch.
0.4 millimeter, 0.4 millimeter thick. Yeah, which
Well, that's really cool, man.
which is robust enough. It is quite robust. The rest of the faceplate is 1.5 millimeter thick. It doesn't have a back yet. Like I have to make it a full case, obviously. One of the other things I did was this one here. So this is a little Pomodoro clock I built. So this is a little Pomodoro clock I built. So Pomodoro, the idea is you work for 25 minutes and you take a break, etc. So behind these little things here, there's little buttons. There's a Pomerone display, and just click on this one to go to the next part of the your Pomodoro or your Pomodoro cycle. Not sure why it's not working. Here's the wrong one. Yeah, wrong button. As you can see here, it says standing works. This is where I'm supposed to like raise my standing desk and work. But this is the first. This is actually the first 3D design I did that was actually very practical. So it just contains a little Raspberry Pi in there. The Pomerone screen has 4 buttons on it, and I just made these little indents just to allow the button to be pressed relatively easily. So I'm quite happy that it doesn't require the Raspberry Pi is screwed into the back, but the lid is just held in there by friction. So the 3D printing is precise enough that it doesn't need any sort of latches or anything like that. It holds it well enough. So yeah, just another little thing. Cool. Yeah, I guess Hall effect sensor. So I see in the chat there's a few comments or questions. Hall effect sensor, I think, would do exactly the same thing. I don't think there's any necessarily advantage. Maybe the Hall effect sensor might be a little bit more robust. The thing with the reed switches is they are glass, so they're easy to break. Crimp connectors are very fiddly. I use the engineering, the company's called Engineering. It's a PA09. It's a very famous one. It doesn't have any fancy ratchets or anything like that. You do have to get used to using it. I guess one of the key things to crimping, I think, is make sure that you don't use too much force. It's easy just to think you have to press it really hard, but it's a Japanese-made crimper, and I think they've made the handles to the right length. So if you have a really big, long handle, you're going to get a lot of force from it. So if the handle's quite short, they're trying to make sure you don't over compress the crimp. So I think it's quite well made. I would recommend it. I think there may be, it depends how much money you want to spend. It's not super expensive. It's not super cheap either. There are some much cheaper sort of ratchet types, but if you read online reviews of them, there's a lot of bad reviews for a lot of crimpers out there. So yeah, check out the Engineer PA09. It's quite well known, well respected, but it's not fancy. It's a lot of manual work. It means that you have to crimp it twice. Every crimp you have to crimp twice. You crimp onto the conductor and then crimp onto the insulation.